Welcome to Learn to Code with Rust. My name is Boris Pascaver, and I'm a software engineer and consultant based in the New York City area. I'm excited to introduce you to Rust, a fast, safe, and modern programming language that is rapidly rising in popularity. So first up, what is Rust? Rust is a systems programming language. Systems programming refers to a category of languages that are optimized for situations where resources are limited. When we refer to resources, we mean the computer's memory and CPU. We'll discuss those terms in greater depth later. There's other systems programming languages out there like C and C++ and Go, but Rust's language design enables the speed of those languages, but with additional safety and stability. Rust was developed by Graydon Hoare while working at Mozilla, and it made its public debut in 2010. Today, Rust can be set up on all modern operating systems, including Windows, macOS, and Linux. So what can Rust build? Quite a lot. Rust can be used to build command line programs, build tools, device drivers, databases, other programming languages, web applications, operating systems, and more. And it's that versatility that explains why Rust is used by many different companies today, including AWS, Microsoft, Firefox, Cloudflare, and Discord. Now, there are many different options for programming languages out there, and there's several benefits to learning Rust specifically. First up, Rust programs are safe, fast, and efficient. Rust also combines the best features and patterns of existing programming languages, but also introduces new ones. So whether you are a new developer or an experienced one, Rust will likely teach you something new. In addition, Rust is skyrocketing in popularity. And truth be told, due to Rust's complexity, Rust jobs can often command pretty high salaries. So I want to close this lesson off with some fun facts for you to get you excited about Rust. First up, Stack Overflow's annual developer survey has found Rust to be the most loved developer language for 8 years running, and that speaks to the fact that the language offers something new and fresh. Twitter's Jack Dorsey has called Rust a perfect programming language. And another fun thing, Rust developers are called Rustaceans, which comes from the term crustaceans. You'll notice a lot of Rust terminology in the documentation has a nautical or a sea-based theme. It's a nice tongue-in-cheek aspect of the community. All right. So that's all there is to cover in this lesson. In the upcoming lessons, we'll install Rust on our computers and then get started learning the language. I'm super excited to introduce you to Rust. I know we'll have a lot of fun. And with that, I will see you in the next lesson. In the following lessons, we'll set up Rust on our computers. Before we get there, I want to explain exactly what we're going to be installing, which is the Rust compiler. In order to understand what a compiler does, let's begin by talking about source code. Source code is the code that we developers write. If you're new to programming, the simple way to describe source code is a sequence of instructions that we'd like for the computer to execute. The Rust source code looks different from source code in a different language, like Python or Java, but it's all source code at the end of the day. It is code that is meant to be readable by humans, by developers. The problem is that the computer cannot understand the Rust source code itself. So that brings us to the compiler. The Rust compiler is a program. It's a piece of software that translates our source code into an executable program that the computer can understand and execute. That executable program is often called a binary or a binary executable, and the computer can understand the instructions in that binary. Now I have the definition of compile on the left-hand side, and the computer science term derives from the regular definition, which is to produce something by assembling information collected from other sources. That's basically what the compiler is doing. It's assembling all of our source code together and using it as the basis to produce something else. In this case, the binary executable that the computer actually runs. So you can think of the compiler like a language translator. All right. Now that brings us to syntax. Syntax describes the characters or symbols that developers use to write source code. It can vary from programming language to programming language, but these are the words and constructs and symbols that we use to write code. Some of them are alphabetic characters, and others are symbols, like, for example, the comma or the semicolon or the exclamation mark, right? So syntax is simply describing that combination of characters that we use to write code. Now, programming languages are very strict, and Rust is among the strictest of them all. Every detail matters to the compiler because it needs to have the source code be valid and legitimate so that it can translate or transform or compile that source code correctly into the binary executable that the computer needs to run. I want to bring up some very common syntax mistakes that a lot of beginners make, and I want you to be mindful, if you're new to programming, to be careful in addressing a lot of these syntax things, right? So for example, case sensitivity is something that matters a lot in programming. Case sensitivity refers to the casing of characters. A capital letter in your source code is not equal to a lowercase letter. A capital letter Z, for example, is different from a lowercase letter z. Another example is spacing. Spaces matter. One space is not equal to two spaces or no spaces. Symbols matter. A semicolon is not equal to a comma. Line breaks matter. A line break is whenever you press the enter key to make the content continue on the next line. Those line breaks matter. Brackets matter. Parentheses matter. All of these symbols add up to the syntax of a programming language, and the compiler needs your syntax to be correct in order for it to be able to translate the instructions into the binary executable. Now, if you make some kind of error, it's not a problem. The compiler will identify the area of the code that it is unable to parse. So what I recommend you do as you proceed throughout the course is you follow the exact content that I have on the screen and make sure you copy everything, including the case sensitivity, the spacing, etc. And then make sure you have a working program and that you see the exact result that I see on my screen. Then I encourage you to play around and try different syntax options. Try experimenting with the code to get a different output. But make sure your first execution works as well, because that is the validation that you have written the correct syntax out. There's nothing wrong with making mistakes. There's nothing to be scared of. The compiler will tell you if it is unable to translate, but you have to get into the mindset of a programmer, which is being extra careful in paying attention to these small details that may otherwise not be pretty concerning. There's a lot of times when you're writing or explaining something to somebody else in text that you can get away with some of these differences or variations. Programming is a lot stricter, and the compiler will hold you responsible. So make sure you are paying attention to your syntax. All right, that's all there is to cover in this lesson. In the follow-up lessons, we're going to start installing the Rust compiler on our operating systems. This next sequence of videos focuses on installing Rust